In this video, we are going to learn how to identify functions from tables. For linear equations, the pattern is going to be either adding or subtracting. If you think back to when we learned about arithmetic sequences, you'll have a common difference. So you always are adding or subtracting the same number every time. For exponential functions, the pattern is multiplying or dividing. If you think back to what we learned about geometric sequences, this is where you have a common ratio. And for quadratic equations, this part's a little bit new. Here we're going to be looking at the second difference, and the second difference will be the same. And I'm going to show you what that looks like. So let's look at the linear function here. Here we're given a table of values. And what I'm going to do is just look at the patterns. So to go from -3 to -1 or -2, I add 1. To go from -2 to -1, I add 1. From -1 to 0, I add 1. And from 0 to 1, I add 1. If I look at the right side, to go from -7 to -5, I add 2. To go to -5 to -3, I add 2. To go from -3 to -1, I add 2. And to go from -1 to +1, I add 2. So this one, we found a slope actually. We found the change in y over the change in x, which is 2 over 1, which is 2. So this one is linear because here we're adding the same thing every time. If we look over here at exponential, to go from -2 to -1, I add 1. To go from -1 to 0, I add 1. To go from 0 to 1, I add 1. And to go from 1 to 2, I add 1. If I look at the right side for the y values, to go from 2 to 4, I add 2. To go from 4 to 8, I add 4. To go from 8 to 10, I add 2. And here, to go from 10 to 12, I add 2. Let me just go ahead and fix something here. This last number should be... Let's fix this. This will be fixed on yours. Let's make this 16. And let's make this one 32. So then if I fix this here, to go from here to here, I would add 8. And then I would add 16. So there's definitely a pattern here, but it's not consistent. Right, I'm not adding the same number every time. So my pattern of adding isn't really working here. So let's try a different pattern. So let's see. To go from 2 to 4, I can also multiply by 2. To go from 4 to 8, multiply by 2. 8 to 16, multiply by 2. And 16 to 32, multiply by 2. So here, this one is exponential because we are multiplying by 2 every time. Now let's look over here at this quadratic. To go from -2 to -1, I add 1. From -1 to 0, I add 1. 0 to 1, I add 1. And 1 to 2, I add 1. To go from 2 to 0.5, I subtract 1.5. To go from 0.5 to 0, I subtract 0.5. To go from 0 to 0.5, I add 0.5. And to go from 0.5 to 2, I add 1.5. What we're going to look at next is something called the second difference. And so we're going to look at the pattern between here. So how do I go from -1.5 to -0.5? Well, I add 1. How do I go from -0.5 to +0.5? We add 1. How do we go from 0.5 to 1.5? We add 1. So because the second difference is the same, that makes this quadratic. So let's look down here at these examples. On example 1, we want to figure out our pattern. So to go from -2 to -1, we add 1. From -1 to 0, we add 1. From 0 to 1, we add 1. And from 1 to 2, we add 1. So now that we've figured out our x's, let's go ahead and look at our y's. To go from -1 to +2, I add how many? 3. To go from 2 to 5, I add 3. To go from 5 to 8, I add 3. And to go from 8 to 11, I add 3. So is this linear, exponential, or quadratic? This is linear because we have a common ratio. Or not common ratio, common difference. Here we're adding 3 every time. The pattern is addition. So this is linear because the pattern is addition, meaning we have a common difference. On example 2, to go from -2 to -1, we add 1. -1 to 0, we add 1. 0 to 1, we add 1. And 1 to 2, we add 1. Now, don't let these fractions right here throw you off. If they are, kind of ignore them and just look at the pattern over here at first. How do we go from 2 to 6? Multiply by 3. To go from 6 to 18, you multiply by 3. Well, let's see if multiplying by 3 works to go from 2 over 9 to 2 over 3. If you're not sure, you could plug it into Desmos. So if I pull out my scientific Desmos, I'm going to 2 divided by 9 multiplied by 3. And then I'm going to click on this fraction button, and it gives me 2/3. So that works. Let's see if 2 divided by 3 multiplied by 3 gives me 2. And that works. It does. So the pattern across the board is multiplying by 3. So if we're multiplying by 3 every time, does that make this linear, exponential, or quadratic? Well, we are multiplying, so it's exponential. So the pattern is multiplication. And so here we have a common ratio. Let's look at example 3. To go from -2 to -1, we add 1. -1 to 0, we add 1. 0 to 1, we add 1. And 1 to 2, we add 1. To go from 1 to 0, we subtract 1. To go from 0 to 1, we add 1. To go from 1 to 4, we add 3. And to go from 4 to 9, we add 5. So this definitely is not linear because our pattern is not the same for adding or subtracting the same number every time. We could look to see if it's exponential. 1 times 0 is 0. 0 times anything is going to be 0, so multiplying is not going to work. So this is going to have to be quadratic, but let's double check and see because sometimes you might get another type of a function that's not linear, exponential, or quadratic because there are lots of other types of functions out there. Rational equations, radical equations, logarithmic equations, the list goes on and on. So let's check to see if this is quadratic by finding the second difference. How do we go from -1 to +1? We add 2. How do we go from +1 to +3? We add 2. How do we go from +3 to +5? We add 2. So here, our second difference is the same, making this quadratic.